and I'm an iOS developer at SuperShark. I've been developing iOS for now 3 years from now, and my biggest passion at this moment is machine learning and augmented reality. And then I think a couple of months ago I started to dig deeper into this topic, and I'm really excited about this. I've done 2 or 3 presentations already. I'm going to do a couple of ones later. But so that's why I decided to bring this topic today, because it's a very hot topic on the development community. Before I start the presentation, I would like to ask one thing. How many of you are developers? Can you raise your hand, please? Keep your hands up if you already work with ARKit. Great. Cheers. Great. Cheers. So, before we go to code, I would like to try to explain more or less how does this magic works. The AR frameworks on Android, on iOS, or any other platform, they fundamentally have something called visual inertial odometer. This is a feature that combines camera data, so light estimation, proximity, with core motion. On Apple's case, core motion, which is the framework regarding your movement. And this feature provides a very high accuracy and stability, which gives us a better experience. And also, it was good because a couple of years ago, before this framework was published, if you wanted to do some experience like this, you would have to use other languages and also some sort of hybrid application. Using C++ into Objective-C code, which was Objective-C++. Not a very cool thing, I tried. And you also would have to run with Unity, and some people didn't like, because to run with Unity projects you would have to know C# or JS to do the animations. And it turned out that it wasn't a very easy thing to do. Nowadays with the ARKit you can do everything on iOS, Objective-C or Swift, so it's not a big deal. This is the feature more or less working like an example. These are our points of the framework or motion, which interacts with this visual inertial odometer. Gyroscope is like the position of the phone. Pedometer is like how far are you from the point that you started, and the accelerometer also like the movement, recording this and deciding all this data. So you can see here that it kind of recreates your position and how far did you walk from the point that you started. And like this, it's easier because it kind of like when you have like a table view, for example, that reuses your experience, so it doesn't have to re-render it. So the experience becomes more fluid and more faster. That's why this experience is like super fluid with the framework. Some requirements to use the ARKit is that you have to be running iOS 11 on your device. You need A9, A10, or A11 chip, which means that you need an iPhone SE, 6S, or further. So if you have 6, no good. And you have Xcode 9 to get the SDK from iOS 11. So, before we start this, fundamentally, ARKit is camera. Augmented reality is the camera. So you have to go to the plist file, your info plist, and then put like a NS privacy for the camera, and create a message saying like, hey, I would need to use your camera to show you this. You know, this pop-up when you open an application that uses the camera, and then it asks your permission to allow to use the camera. You need to put this string on the info plist file. Okay, so the main component of the ARKit is AR-SCN view. This is where this is like the camera view, and it's gonna show you like the normal camera that we use when you open the camera on the iPhone. But then you'll be able to set up nodes, geometries that we're gonna go further here in this presentation. But so the first thing that you're gonna do in code is that you're gonna import the ARKit. I choose Swift because nowadays everyone uses Swift, so I just didn't thought about this. But yeah, you import the ARKit framework, and then you declare 2 things. You declare an outlet if you're using storyboards. You go to the storyboard to your zip file, and then you put drag and drop AR-SCN view, and you connect to the outlet, and you declare a constant for AR board tracking configuration. This constant will tell your device that you're gonna keep track of your position the whole time. Like if you have the AR-SCN view open, if you have the session running, it's gonna track your position and track your movement. Once you've done that, you just have to run the session, passing the configuration as a parameter. These debug options it doesn't affect anything. It does not affect anything on your performance. But it helps you when you are like for example, when I was starting to learn this, I was using these debug options because they give you, for example, these two debug options here. This world origin is like whenever you start the camera, if you go back a bit, you're gonna see triple axis, so y-axis, x-axis, and z-axis, just to see like where is the origin of the experience. These feature points are like, I don't know if you have seen already some videos of AR, but when you track a surface, it shows some yellow dots. This is saying that we tracked the surface. Okay, so once you've done this, you just have to run the session. You don't have to instantiate this session because it already includes our AR session instance, and pass the configuration as the parameter. But at this point yet, you just have the camera. If you put the debug options, you will have something, but still it's nothing that you added. It's just this tracking debug options. It's just this axis or these feature points. But you haven't added any object yet. But to add an object to the scene, to add a geometry, for example, you need to understand the concept of node. Node, Apple gives us this description here, which is like quite colored. I'd rather say that it's just a position in the space that you can attach geometry, light, or every other type of element. So, on the Xcode 9, you can use the interface build to drag and drop these geometries that comes out of it, comes with it. Or you can set up your own geometry using a scene kit file. And you pretty much, if you want to do a complex geometry, you're going to use a group of this native geometry. So for example, if you want to do like the Android robot, you're going to have to do like a cylinder and then like 2 cylinders for the legs and this and that. But pretty much you're going to use this native. Or you can use extrude tool for you use like a Bezier path and then you extrude it, which is like cool, but you're gonna need some quite an experience with modeling, which is not very easy. Once you choose a geometry, for example, let's suppose that here in this case we choose a sphere, because in this example I'm going to show you how to do the plane area. So just extending that code, I created this function called addNode, and we instantiate the node and we pass these 3 things here and then we add. The 3 things are position, geometry, and texture. I set the position. This is a 3-dimensional vector, starting from the origin, so where your scene started. You pass the x-axis, y-axis, z-axis. The measure unit is in meters. So if you put like 1 meter here, in this room here, maybe you will be fine. But if you are in a bathroom or something like that, it will be too close and it will be like a weird experience. So not very, very cool. So I recommend you that if you never tried it first, try it with centimeters. It will be like better for you. So in this case, I set the position with a 3-dimensional vector. I set the geometry that I wanted. You can put SCN sphere, SCN cone, SCN pyramid, or any other of that elements that I told you before. And then I'm going to set the texture. In this case here, I'm setting a color as a texture. You have to assess first material, diffuse for the. So there's a difference between diffuse and specular. I'm going to show you on the other slide. But here, I'm not setting any texture. For example, I'm not setting any image as texture. I'm setting it a color. And specular, I'm going to show you on the other slide. Okay, so auto-enable default lighting is because when you put in the scene an object, you don't have any light applied to it. So you can either put auto-enable default lighting, which will give you some effect similar to a like if the light was on the camera, which is not very cool, but still is like make the experience faster. If you want to do something more realistic, you should use light estimation. You should enable light estimation. But then, if you don't have a very good device, your experience goes slower and slower. If you want to check your FPS, the frame per second, you can just on the session you can allow the show statistics. Is a flag that you're going to set there, and then you're going to show you a statistic on the bottom. And then, of course, you have to add the node to the scene. And every scene has a root node. But further, you're going to see that you shouldn't add everything to the root node, because otherwise they're going to inherit some properties in common, which is not very cool. We're going to see it further. So this is the only node that we have so far, and then we add it to the root node. And this is the experience we have. With this code, this is the experience that we have. In this case here, we just have diffuse. In this case, we have diffuse and specular. So my definition for diffuse and specular is that Diffuse is the color or the texture that you can see on the geometry, on the object, on an ambient light, for example, without any reflection. And specular is the other way around. So the color that you would see if you had a source of light directly pointed to it. In this case, that is directly because it's auto-enabled diffuse light. Here are two types of textures that are not colors, not anymore in this case, that I got in this website here, Solar Systems Code. This is a diffuse and this is a specular. Why this is specular is just black and white. Because the land on the planet Earth doesn't reflect light, but the water on the other hand reflects light. So whenever the light points to this point, it's not going to reflect any light because it's black. But if the light is pointing to this point here, it's directed to this point here, it's going to reflect white. So this is the experience with these two textures. This is much more realistic. I don't know if you guys can see the difference more or less, but when I put the specular texture, it gives you much more realism of the experience. Okay, so action and action inheritance. Continue again with the code that we had before. Here, I'm going to put not just the Earth, but I'm going to put also a moon. So another node with a smaller radius, a sphere. Oh, I forgot to say one thing. Every geometry has specific parameters. So for example, if you're handling a sphere, there's radius. But if you're handling a plane, there is like height and width. If you're handling a cube, there will be height, width, and depth. I don't know. So for every geometry, you're going to have specific parameters. For sphere, we just have radius. Okay, so I set the node for the moon. I set the distance from the root node. Yeah, so in this case here, I'm not setting to the root node. Why? Because if I set to the root node, the distance will be relative to the root node and not to the Earth. And if I apply actions to it, it will be the same system. So if I apply one action to, I don't apply action to geometry, but I apply action to the node. And for example, if I have the Earth and the moon on the same node, and I apply a rotation action, for example, they both gonna rotate. But I don't want that. I want the moon to rotate around the Earth. So I apply a rotation action to the moon, to the Earth, and then the Earth gonna spin. And since the moon is a child node of the Earth, it's gonna rotate around it. I don't know if I made myself clear. If you have any questions, you can put it on the slide below, and then we can talk later. Okay, so I added the moon node as a child of the Earth node. What else? And then SCNAction. There's rotate, there is like movement, there's like a couple of actions that you can apply. It's super simple. You just have to say which axis you want to rotate. So in my case here, I want to rotate on the y-axis around it. So pi times 2. The duration of the whole animation, 10. And then you can say also repeat forever. So just to make the example goes on to ever. Also in the interface builder, you can drag and drop actions also. I don't think that is, yeah, maybe it's easier. It's what you prefer. You can do it by code, like I'm doing here, or you can just drag and drop from the interface builder. And this will be the effect that you're gonna have. So you see that the moon itself is just spinning around this y-axis, and the moon is spinning together on the same velocity, but for example, on the same speed. But for example, one time I wanted to do an example of the whole solar system, and the sun was spinning in one speed, the moon, the Earth, and all the planets were spinning in different speeds, and that was tricky. I had to do one node for each planet that I wanted to turn on. Every node was with the center on the sun, and many nodes on the same place, because there's no problem with that. Many nodes on the same place with different rotation speeds. So I don't know if you understand the way that I tried to do there. If you want to use an external 3D model, so for example, let's suppose that you want to do like a transformer. I see that on the board, a transformer, and you're gonna spend like your whole life trying to design that with circles and planes and cylinders. So for example, let's suppose that you can go on a website, for example, TurboSquid or Free3D or many other websites, and just download the 3D model. You have to download on a specific extension, which is called DAE, Digital Asset Exchange. You can ask for your friends designers also to export in this extension. And once you have that, you just drag and drop to your interface builder. and it's gonna appear this palette here for you, so you can set all the properties, no code at all. Just drag and drop and set the color here. Once you have done this, it will still be a different extension, and then you just go on editor and then you say convert to syncgate file format, not SCN, and then you're gonna have the syncgate file property. This is the code. Once you have done all this, this is the code to do this. You're gonna set SCN scene and pass the name of the asset, pass the name of the catalog. This is the name of the catalog that the asset is in, and this is the name of the scene. Jellyfish scene, root node, child node, the same stuff that we did before, but this time passing with name, which is the name of the node, and recursively false. Why recursively false? Because, let me go here. Why recursively false? Because in this case here, we're just gonna have a, let me show you yeah, here. So once you added that, if you only have like jellyfish, for example, here, recursively is false because it doesn't have to look inside of every node that is here. But in this case here, it will be true. If we wanted like to get inside instead of jellyfish, we would have to put like recursively true and pass it inside as the name. But in this case here, that is the example that I'm talking. Recursively is false. And that's what it means. It's recursively. Updating render with different anchors. So maybe you also see some videos on the internet where you put the camera, like for example on the floor, and it turns out that the floor starts to become something, some plane. For example, when I was learning in this course about the ARKit, this guy was putting some texture of lava in the floor. And how does it work? You just have to set the delegate, the configuration plane detection horizontal, so there is only horizontal and none. On the ARKit 1.5 there is vertical, but so far now, because the ARKit 1.5 is like beta iOS 11.3, if I'm not wrong. So you set horizontal and you set the AR scene view delegate to the scene that you are using, and you implement the 3 delegate methods. I forgot to put one here, but it doesn't matter. This one is did add and this one is did update. Did add is when you scan a surface and it adds our plane anchor. It does this automatically. And this AR plane anchor has the following informations, which I don't put here, but yeah, it has like a position, size, orientation, position. And once you have this information from the camera, you can it's gonna call the first time you're gonna call did add for the plane for the AR plane anchor. And once you, for example, you go away from the point that you started to track, it's gonna update. The phone gonna realize that the surface was much bigger than he actually thought. So it's gonna call that delegate method did updated plane anchor. And then what you can do, for example, if you want to put the same texture on the whole floor, for example, you just have to remove the node and then add a node with the new information that you have, the new size, the new position, the new orientation. This flag here, double-sided, is just to see, for example, if you are under the sprite, if you're under the texture, it will have the texture, and if you are above the texture, it will have also the texture. What else? So just what I just said, the did update. So for example, let's suppose that the camera go out, and then it discovered that the floor was bigger, and then it removes the node, every node that is on the parent node, and then it calls create node again with this new information, this new size. So we set up scene view, we set up nodes, we pass the geometries, external 3D models, we set their position, we apply action, textures, and light, and we updated their size, orientation, and position using anchors. These are some examples of what you can do with the ARKit. These are tweets that I found on the internet that are very interesting. This is using core motion, and it's gonna apply the ARKit into navigation, which is pretty cool. This guy here is using image detection, so this example here is not purely ARKit. This guy is using core ML for sure. He has to understand that the cover is this, and that, so it's just not purely ARKit. Also, the guy there is using core ML for sure, because it's super nice, the example, but it's not that easy. Maybe I have some more here. These are super cool experiences. Also, I'm trying to reproduce this nowadays, which is called spatial mapping. I don't know if you remember the first GIF that was here. This guy here, you can see, maybe not because of the light, but he has a line here that is following him and recreating this scene that he's seeing on a 3D model. Oh, that's all. Thank you. I forgot. I thought I had more. Thank you. If you have any questions, you can put it on, or should I check now?
Yeah, we should check slightly.
Okay. Let me see if I have some questions.
I'm pretty sure you do.
Okay, I have a couple ones.
Yeah.
Did you found a site with good collection of 3D models? It depends. Do you have money?
Do you found a site with free?
With free, you say free. You don't say free. But for free, no. For paid, yes. But it costs.
Maybe Thingiverse?
Huh?
Archive 3D.
ARKit 3D.
But you have to take note that you need this extension. So it's like a little bit harder to find.
It can be converted.
Yeah, it can be converted for sure. So this one that I put here, Turbo Squid, has some, but they're not very high quality. The high quality ones are paid.
It's out.
Okay. Can ARKit detect the dimensions of the rooms? I mean, yes. There is a measuring part of the ARKit which is really nice. Actually, I can talk about this. You can add me on Facebook or something, and we can talk about this. It has been proven that ARKit, the measure accuracy is pretty good. Actually, people are using this. My mom is an architect, and she's using this to create. I don't know how to say that in English. You know, when you do a reverb, and then you have this stuff from the upper part. How do you say that in English? Floor plan. That's it. My mom is doing this at distance, so like there is a very good accuracy on that. And yes, it's possible. Can I have animated objects? Yes. The animations are the actions that I did, and also you can apply CA basic animations to it. No problem. It's the same thing with views, 2D views that we used before on Visual Studio. Did you release an app with ARKit in production? No, I never released an app with ARKit in production. I want to, but I have a work, and nowadays this ARKit is only used as a mock application or as a concept application, but production apps nowadays, they don't invest this too much. On my free time, I like to do some stuff to try out, but nothing professionally, just to check out how is the technology going. But yeah, my work on a daily basis, no. It's not that yet, but I guess it's going to come soon. Can you tell an ideal size room to try ARKit? I think this one is cool. I think this one here is cool. Because you can see the walls very clearly with your phone. I think it's a pretty good size, this one. Is there no other way to draw 3D objects or 3DS mocks?
That was me before you showed that slide.
Yeah. Okay, so you got your answer?
Yes.
Okay, cool. Okay, so if you have any other questions? Yeah,
What are the limitations of the models in terms of like triangles?
Do you, sorry,
How
can you?
if the object is very difficult, it's very complex, do you have any limitations that the ARKit can read?
I see. I haven't checked that yet. It's like, for example, if it has too much triangles.
Exactly.
I see. Yeah, actually, I never looked into that, but probably yeah, because the rendering is not that powerful since it's a mobile. But actually, I have someone in my work that is really into it and is a designer. I'm gonna ask him to provide me a model with like 1 billion trees, and I'm gonna try to convert to it, and I can give you a feedback about this. Good. You have another question?
Try AR4 yet?
No. But AR4, the Android one.
Yes.
No, I haven't tried it yet. You tried it?
No.
No. I heard it's a good one. I heard it's stable as well. But I'm an Apple fanboy, so I'm sorry. I can do that with me, Steve Jobs. Okay, so if you guys have any question, you have another one?
Yeah. Is there a visual interface where you can see instead of coding, putting together the whole scene?
Yeah. You can use the interface builder. You're a developer? Have you seen Xcode sometime?
We use Unreal Engine.
Unreal Engine, yeah. So I don't know how
Something
it's
similar.
So the Xcode, which is the IDE, the Integrated Development Environment from Apple, it has something called Interface Builder, which is basically a drag and drop. I don't know if you know Unreal Engine is that.
Yeah.
So with that, you could just drag and drop the geometries that you wanted to use, and drag and drop also the actions. Of course, you wouldn't be able to do complex scenes, but you would be able to do something. Good. So thank you very much, and we see you around.
Thank you.